Hi, in this video we will cover how to create multifaceted plots. The idea is to find ways to add more variables into our analysis when we are visualizing our data. So with the purpose to compare different distributions when we include the variables, we will use here two libraries. We will work with Seaborn and Plotly Express. Okay, so let's get started with our first dataset. In our first example, we will use the iris dataset. It's about flowers. So there are three different species, and for each observation, there are four numerical variables: the sepal length, sepal width, petal length, and petal width. Okay, so when you want to explore all numerical variables, an easy way and to check whether there are some relationships among our variables, and a quick way is to use pair plots. So let's create a pair plot for the iris dataset. This is how it looks. It's going to create a matrix with all possible combinations of the variables that we have here. So the interpretation of this pair plot, which again are all possible scatter plots, is that this will take all numerical variables. Now, what you see here in the y-axis, this sepal length is gonna be the y-axis for the first row. The sepal width will be the y-axis for the second row completely. So all these plots, except the histograms, but the other plots, these scatter plots, will have this variable in the y-axis. Now, in the x-axis, we have here the sepal length. So this x-axis is going to be for the whole column, right? So each plot is just intersection of the row and the column. For example, this one right here is going to be the sepal width in the y-axis, and in the x-axis the petal length. So with the scatter plots, with the pair plot, you can see if there are relationships, like between like every single pair of variables. So here it's not the case, but if there is a y or dependent variable that you want to predict, so first you will focus in that row to see if there are relationships between that variable and each of the other independent variables. Now in the diagonal, what you see is the histogram, because it doesn't make sense just to plot a scatter plot between the same variable in x and the same variable in y. That does not add value. So instead of showing you a plot that is useful, that is not useful, it's better to just show you the shape of that specific variable, and that's how we get the histogram that you see here in the diagonal. Okay, now we can use facets to recreate this same idea, and they are a little bit more flexible. So the question here is, do different species of flowers have different relationships between sepal length and width? We can answer the question with the pair plot too. So let me show you an easy way. We can add the color, the hue, for adding the variable species into analysis. And now it's way more clear when you see the species. Now it's clear that there are some differences, right, for the different variables. So there are some flowers that are smaller compared to the others, right? Even in the distribution, if you check now instead of history, we get here density plots. So you see that they are shifted, right? They are not aligned, meaning that they are different, right, for the different variables. Okay. So now we're going to use facet grids to do a similar analysis to compare the sepal length, sepal width, and to see if it changes with the species. So I'm going to use Seaborn for that. Facet grid. We use the dataset iris, and I use the column as the species. It's going to create multiple plots, like multiple columns. There will be 3 columns in total because there are 3 species here. If I leave it like this, I will get an empty plot, right? Only with the name of the species, right? But now we need to provide information of X and Y. So one way to do this is to save the initial plot and then map the scatter plot. So let's add the sepal length. These values are in the question, right? And the sepal width. All right, so let's find if there is an error here real quick. Oh, the problem is like the age, right? There was an error with the variable name. Okay, so now we get our 3 plots, right? The multifacets. In the first one is for setosa, versicolor, and virginica. So you can see that there are differences, right? In the case of the setosa, for example, the sepal width is higher, the values compared to the other 2 species, while the sepal length is smaller, right? Now, the versicolor is like in the middle, and the sepal and the virginica has like higher values for the sepal length. So you can see the differences. So clearly, they have substantial differences in some of the variables of interest. So we can classify them or cluster them. That's based on our initial analysis. All right, so let's continue. And now in the next question, we will use a passengers data set. And the question is, how do airline passenger trend vary by year and month? Focus on the last 5 years. So first we load the data set. And now let's plot. You're going to use a line for this. So first, we create the facet grid. Flights. Now the column here is going to be per year. Okay, and now let's map line plot. Using C1, is using line plot. And the variables of interest, right? So in the x-axis, let's have the month. And in our y-axis, the passenger. So it's not finding the. So just going to verify if I have a mistake. So remember always to visualize your data. Oh, I'm missing an S, right? Passengers. That's why it does not recognize the name of the variable. Right now, it's creating multiple facet grids. If you see, there are too many columns, right? Because there are a lot of years here, so it's difficult to follow. Now, there are multiple ways to cope with this issue. One, we can filter our data because we want to focus on the last 5 years. That's one alternative. And then I will show you in Plotly how to wrap the column. So you can define like the maximum number of plots that you want to see, you know, like how many columns you have. If I say, for example, 4 columns, then it will only create 4 columns, so it's going to create more rows to accommodate the remaining plots. Okay, in this case, let's filter our data because the question is to focus on the last 5 years. So I'm going to do that. It's important to know what are the values of the last few years. So there are multiple options to see this. Let's do it for a year. You can count values. There are multiple ways. So the last years are 1960, 1959, 1958, 1957, and 1956. So these are the last 5 years. All right, so now I'm going to filter some flights, year, but different, greater equal 1956, right? Let me confirm that. 1, 2, 3, 4, 5. Yeah, that's correct. So now it's creating only the last 5 years. When you're having these problems, like the way in which you cannot see the labels, you can adjust the size of the plot. You know, you can play with that part. For example, here, let's try something just to see if it works. I'm going to change the height. It works. It works. Now I can see the months, right? Which was a problem initially. Okay, so as you see, now you can see per year, you can see the time series. And you see that it's increasing, right? You can see that during the last 5 years it's increasing. So the minimum values are increasing. And at the same time, there are some patterns, like here in the summer period, the airlines experience like a higher number of passengers, right? So it's a high demand season. So yeah, these are the type of things that you can see better when you have a multifaceted plot like this one. All right, let's see more examples. One more. In this one, we're going to check the brain activity, the signal, a signal in the brain activity. For that purpose, we will use the dataset, an inbuilt dataset, the fMRI. We load it, and the variables here of interest, the signal, of course, there is the numeric variable of how strong is the signal. The region, so there are two values, the parietal or frontal region. There are two events, that's the other variable, stimulus or control event. The control event is just to have like a baseline to be able to compare the signal. Now the question is to check whether there are differences, right, according to the region and the different events over time. So we use a facet grid for the data set. In the column we use the region, and for the color we use the event. Let's use line plots. In the x-axis, the time point, where we measure the signal, and in y-axis, the signal. So now we can compare the signals for the two regions, for the parietal area and the frontal zone. As you can see, in the parietal area, the signal, the measurements are stronger compared to the frontal, right? And same thing between the two events. You can see the difference between the control and the stimulus. All right, now our last example is going to be with tips. We have used this dataset in previous lectures. Now, same idea, let's compare the tips value for gender and the day of the week in this dataset. Okay, so for the purpose, we use Facet grid, tips, column per day. use X to compare both. In this case, we'll use a box plot. In the x-axis, we'll have this X, and in the y-axis, the tip. So x-axis, you have sex, male, female here, and the tip is the y variable. But now we have multiple columns, right? We said in the column we'll use the days. So here we have Thursday, Friday, Saturday, and Sunday. And you can compare the median values, and there are differences, right? Here, for example, in Thursday, there is a slight difference. However, as I have mentioned in previous lectures, it is important to be cautious here. You can so far formulate a hypothesis, but you need to check that. You need some hypothesis testing to verify and to make an inferential analysis here to check if they are different or not. Same thing in Friday. During Sunday, they look closer to each other, but again, if you wanna be like have more, you wanna reduce your uncertainty, I encourage you to perform a hypothesis testing here. Okay, let's do the same plot, but now using Plotly. I think Plotly is easier in general because it's okay. Plotly, the box plot, the data set tips. In the x-axis, in the y-axis, the tip. In the x-axis, the sex, the gender. So it's the same thing. Now, here in Plotly, the columns, we call them facet columns. There are also facet rows if you want to add another categorical variable. This is optional. The category order is optional. Is when sometimes when you have a categorical variable, the plot does not show like in alphabetical order. Or in this case, it's not about alphabetical order. It's more about the day of the week. Like for example, you want to see this order: Thursday, Friday, Saturday, Sunday, right? And not like Friday, Saturday, Sunday, and Thursday, because it's a little bit more like less intuitive, right? So we get the same plot compared to Seaborn. However, remember that here you have all the flexibility that Plotly provides. You can hover, like the points, zoom in, zoom out. So it's more interesting when you're exploring. Let me show you one more with the Gapminder. We have used the data set in previous lectures. So now I'm going to create a scatter plot for the data frame. So in the x-axis, let's use the GDP. In the y-axis, the life expectancy. Now these are optionals, but we can add the color. For the color, we can use the continent. And then for size, we can use the population. Again, this is optional. All right, and now to create multiple columns, I'll do it one plot per year. So let's do the facet column. So for the facet column, this a year. So now you see per year, right? However, it's a little bit have too many plots here, right? So it is possible to define the maximum number of columns. So there is a parameter. The same way that there is a facet column and a facet row, there is also like a facet called wrap. Facet called wrap. So we can define it as 3 or 4. It means no more than 4 columns or 3 columns, right? So now I said 4, so there are 4 columns, right? And then we Plotly will use more rows to accommodate the plots. You can do it with 3. It's up to you. And now you can compare the GDP and the life expectancy, right, for every single year. You can visualize all of them, right, in a single plot. And that's the nice thing. You can see how it's increasing, right? Because initially was like these big countries were around 40, and now the same countries are above 60. So you see a huge difference in 50 years. Okay, I'm gonna stop the video for now. I hope you enjoy the multifaceted plots.